First day of this next unit. So this is unit 8, day 1. These are so demanding. So write down unit 8, day 1, please. And write down, this is the exponential function and logarithmic functions. And I will write that down as soon as it appears here. You've already learned about exponential functions during Algebra 1-2, but for many of you, out of all the functions you learned about, linear, quadratic, and so on, this is the one that most often students struggle with. So we are going to review what you should have already learned, and then we're going to take it to another level. Okay, so please write down learning objective number 1. I can graph exponential growth functions. So when we examine what this learning objective is, there's a few words that you should become familiar with. So graphing, obviously, we know what it looks like to graph a function. Now the word function, raise your hand if you remember vertical line test from 8th or 9th grade, vertical line test. How many of you need just a really quick review of what a vertical line test is? Okay, a vertical line test is when they give you, like I'm going to draw real quick, an example of, you don't have to do this. Here's an example of a linear line, a quadratic function, okay? Or maybe we even have something else. Maybe we have something to a higher power, okay? Something x to the 4th power. So if it is a function, that means that every x belongs to only one y function, one and only y value, excuse me. So we can test if it's a function by doing vertical line tests. So I go up and down making vertical lines, and every time I make a vertical line, it can touch the graph of the line at a maximum of 1 time. So 1 time, 1 time, 1 time, 1 time. Okay. So none, but that's okay. 1, 1, 1. Okay, good. 1, 1, 1, 1. So I'll give you an example of what's not a function. Here's a parabola that's been tipped outside. You learned about that with Mr. Edwards during first quarter. So in this case, if I did a vertical line test, you see how I touch it in more than one place when I make the vertical line? So this is not a function. These are all examples of functions. So I know I'm going to graph something that's a function, and it has growth. When you think of growth, do you think of something going up or something going down? So I know I'm going to have something that goes up. It's going to be a function. Now exponential, you learned about exponential again during freshman year for most of you. Some of you is 8th grade. But we're going to review that for you. All right, so this is the basic format that you want to write down. This is the basic format for an exponential function. Y equals a times b to the x. Sometimes this a is hidden. I mean, sometimes you don't see the number. And if you don't see a number in front, know that it's a hidden 1. Your a is going to identify the y-intercept. And b is going to identify the rate. It's going to tell us, is this a growth or decay function? And it'll tell us how fast does it rise, or how fast is it falling. Okay, the very first problem we are going to do together, please write down example 1. We're only going to get through 4 today. We're going to start with some very basic ones. So write down example 1, please. And this first example is going to be y equals 2 raised to the x power. So first I'm going to identify what is that a and what is the b. Well, here's the problem. I see that there should be 2 numbers. The number that corresponds with the base being a number and the exponent being a variable is your b. So in this case, b is 2. Now, you don't see a number out front. So what is the only number that you could multiply by this and it does not change the value? So this is really like 1 times this, even though you don't see that. A is 1. So this helps us, this tells us what your y-intercept is. So your y-intercept written as an ordered pair is 0, 1. So I'm going to go to 0, 1 and I'm going to make a dot. You are going to have this on Monday when you get a guided practice and homework. Now, from this point, as I go over, I like to write 0, 1 off to the side. You're going to focus on this number, this y value. And the y value, you're going to take times the rate. And the rate for this problem is 2. So 1 times 2 is 2. So I move over 1 and I go up 2. Now this new ordered pair is over 1 up 2. Focus on the y value. To get to the next point to the right, take this number, which happens to be a 2, and go back up to the right again. 2 times 2 is 4. So I go over 2, up 4. The new value is 2, 4. Focusing only on that y value to help us determine the next number. So when I go over to 3, I'm going to go up to 8. Over 3 and up 8. And although this would be off the graph, I want you to turn to your partner. If you go over to 4, taking 3 seconds to decide this, what would be your y value? 3 seconds, go. 1, 2, 3. It would be up to what? 16. Can you raise your hand if you're understanding that concept? Okay, and obviously 4 would go with 32 and so on, right? Understand that? So anything to the right of this, I'm multiplying. So when I go to the right, I am multiplying by the rate. And that's only referring to the y value. 1 times 2, 2 times 2, 4 times 2, 8 times 2. Now when I go to the left of the y, y-axis, I'm going to divide by the rate. When I go to the left of the y-axis, I'm going to divide. So here's the 1, right? This is 0, 1. I'm only focusing on the y value. Take 1 and divide it by the rate. 1 divided by 2 is 1/2 or 0.5. So go over 1 and up 0.5. And I want to show you how cool this looks, or how easy it is to understand when we look at this chart. So I'm going to put 0, 0. I'm going to go off the graph here. I'm sorry, not 0, 0. 0, 1. 1, 2. 2, 4. 3, 8. We already determined it would be 4, 16. When you go backwards, watch this. It is over 1, 1/2. Notice this number. Over 2, 1/4. Guess what -3 would go with? 1/8. Now, here's the thing that my previous class, half the kids could understand, half the kids couldn't. You're going to talk about this with your partner in 1 second. Ready? So it's going to go 1/2, 1/4, 1/8, 1/16. At what point, if ever, does that y value turn into a negative based on this pattern? Talk to your partner. At what point will it turn into a negative, if ever? Will it turn into a negative? No, it will never. We're going to get to that in a second. Good. So it would be like 1/4, 1/8, 1/16, 1/32, 1/64. It's going to get closer and closer. It's going to be a smaller and smaller fraction and get closer and closer to this line, but it will never, ever, ever turn into a negative value. So when I connect these, it looks like this, and it looks like this. Okay, that is your basic exponential function. Is everybody okay with that? Okay, we're going to do another one together. Now this time you're going to graph with me. I understand you don't have graph paper, but you'll be fine with that, okay? I did that during first period. Okay, so let's go down to example number 2. What? That first one is okay if you just watch. The second I'm going to have you graph with me. So y equals 2 times 3 to the x. Come off to the side and make a chart, please. Now, with your partner, I understand you don't have the graph paper, but with your partner, I want you to do 2 things. I want you to write down what are the coordinates of your y-intercept and what is your rate. Cassandra, can you sit next to Mr. Cortez? Thank you. Okay, 3 seconds. That won't take long. What are the coordinates of the y-intercept and what is the rate? Go. 3, 2, and 1. Okay, you ready? Anthony, what is the coordinates of the y-intercept? 0, 2, nice job. It's whatever this is. So 0, 2 are the coordinates of the y-intercept. So go 0, 2. That's all that number does. It tells you what the starting point is. It's the sole function of it. Now, how do we create a graph? We create it based on what the rate is. So in the middle of my new table, I'm going to write 0, 2. It's the y value that I'm focusing on. So when I go 1 for the x, to figure out the y value, I go and refer back to the rate. Does anybody have a guess what y is going to, what 1 for an x value is going to correspond to for the y value? Anybody? 6. Great job. And 2 goes with, anybody? 18. Now, how are we getting that? So I go back here. 2 times 3 is 6. 6 times 3 is 18. Okay. So 0, 2. 1 goes with 6. Obviously, this is going to be way off the graph. So here's 10, 11, 12, 13, 14, 15, 16. I'm going to estimate. Now let's go backwards. So if I do -1, I don't have to overthink this. If I go -1, guess what the number is going to be? Take it and divide it by the 3, right? Take it and divide it by the 3. So it's going to be, and I just want to make sure before I write that down that I am doing that correctly. Grab your graphing calculator for me, please. Looks like somebody took mine. Give me 1 second. I just want to justify that that is the correct. So I'm going to plug in -1 for an exponent. Substitute -1 in for x, multiply it, take it times 2, and turn it back into a fraction to make sure we are getting the correct answer. So 3 raised to the -1, which at this point you should know, actually, oh, that key is not working. Thank you for your patience. 3 raised to the -1 pushes it down to the bottom, and you're going to take that. I did it wrong. I put 2. So we're going to take 2. It should be 2 divided by that number. It should take 2 and divided by this number, which is 2/3. That should be correct. So 3 raised to the -1 times 2, and you end up with 2/3. Did you guys get the same answer? Just checking my work here. Okay, so again, 2 divided by this number. And then if we wanted to do the next number, we again would take this number and divide it by 3. So if you take 2/3, put it in parentheses to make sure you have a fraction, divide it by the rate of 3, press enter, math fraction, enter, enter, and you come up with the answer of 2/9. Okay, now we're going to have to approximate when we actually graph this. So I'm going to go over to -1, up to 2/3, and I'm going to connect these points, bring it off to the left, and I'm going to identify what the horizontal asymptote is. The horizontal asymptote is y equals 0. Students in my previous hour were confused. Is it x equals 0 or is it y equals 0 for horizontal asymptote? So they understood that it was along this line, but they couldn't remember, was it x equals 0 or y equals 0? Well, think about all the ordered pairs along this line. Do they all have an x value of 0? Do they all have a y value of 0? Same thing here. Horizontal asymptote of y equals 0. So what is the difference between this function and this function? So, right, this one we didn't see what the a value was. So the a value here, or I'm going to call it the starting point, is 1. So we have a y-intercept of 0, 1. Here we have a y-intercept of 0, 2. Let's look at the rates. Rate. From the y-intercept, you're going to go up at a rate of 2. From the y-intercept, you're going to go at a rate of 3. Do you see how fast it climbs? All right, nice job. Now we're going to talk about, please write down learning objective number 2. Learning objective number 2. We'll come back and analyze the end behavior of those two in a little bit. So learning objective number 2. I'm going to fold this and bring it up a little higher so everybody can see. I can distinguish between exponential growth and exponential decay. So exponential growth, as you can see from the last two graphs, it's things that grow rapidly. So a few examples that you may be familiar with, and you all have had some type of science class, is like bacteria or sometimes cancer. Those type of examples are examples of things that grow real rapidly. How many of you, unfortunately, and hopefully this has not been a close family member of yours, how many of you have heard people that were diagnosed with cancer and within like 6 months, unfortunately, to pass away, right? It grows really, really rapidly. Okay, that's an example of exponential growth. Another example would be, and not always, but sometimes it would be something within the tech business. So when you think about a new invention that's created, something to do with the iPhone, maybe an iWatch, or something that grows really rapidly, right? Everybody's trying to buy them, correct? It's not called iWatch, what's it called? Apple Watch. Don't make Amy, Amy, don't make fun of me, okay? Okay, exponential decay. What? Kevin?
It wasn't me.
You're the loud one. What do they tell you if you're going to be smart with your money? What do they tell you to not go out and buy when you turn 23 or 24 and you get your first job and you're making some money? A brand new car. What do they say happens to the value of the car? For most cars, as soon as you drive it off the lot, it declines rapidly, right? So the value of the car continues to decline rapidly over time, all right? So exponential growth and exponential decay. Exponential decay looks like this. It's going down and down and down. But now when we talk about those Apple Watches, okay, it's going to look something more like this, all right? It's growing rapidly and going up. So this is an example of decay, looking at it from left to right, going down, and growth is going up. You have to read it from left to right. Now, how can you tell when you look at an equation if it's growth or decay? So this is something else you're going to be wanting to write down. This A value has to be positive. In both situations, A has to be positive. So your A value is greater than 0. We'll talk about reflections across the x-axis later on, but your A value has to be greater than 0. The difference is the B value, the rate. If B is greater than 1, we consider it to be growth. If B is greater than 0 but less than 1, we consider it to be decay. So in learning objective number 2, I'm going to write down 5 examples of functions. 5 examples of functions. You are welcome to write them down in your notes, or you're welcome just to discuss them with your partner. I simply want you to decide, based on this fact, or these facts, is it an example of growth or is it an example of decay? Remember, your A has to be positive in both. If B is greater than 1, growth. If it's between 0 and 1, decay. Your B value is the one that's associated with the exponent x. Okay, 5 examples, up to you whether you write them down or not. It's not going to be. Mm-mm. Do you know why that is? What's 1 to the first power? 1. What's 1 to the second power? 1. What's 1 to the third power? Does that make sense? You'd have a constant. Good question. So there are your 5 examples. I'll pull it back down here. And ultimately, all I want you to be able to do is correctly identify is an example of growth or decay. Whether you write them down or not is up to you. I'm going to give you a minute right now to discuss this with your partner, and I'll go over it with you after that point. Remember to have the reason why you believe it's decay or growth. Okay, here we go. You ready? Cardinal, what do you think is the first answer? And give your reasoning, please.
The first answer is going to be decay because B is less than, or not less than, but it's in between 0 and 1.
Nice job. First one is decay because B is between 0 and 1. Next one, Anthony. Because? Nice job. Because B is greater than 1, it is growth. Cassandra? Decay. And why do you believe it is decay? Okay. So is 4 over 3 between 0 and 1? No, you know what? I'm purposely trying to trick you, and I'm actually glad you got that wrong, okay? Remember, for improper fractions, when the number on top is greater than the number on the bottom, common mistake, Cassandra, okay? Number on top is greater than the number on the bottom. It's actually greater than 1. So instead, this is going to be growth, okay? Next up, let's go with Kalel. Decay because? Nice job. And last one is Nick.
That one is growth.
Growth. Okay, we're moving on right now to learning objective, our last one of the day, learning objective number 3. So your last learning objective involves 2 things. One is they want you to be able to make predictions of translated exponential functions, graph them, and then analyze the graph. So there's 3 things. They want you to make predictions based on your prior knowledge of translations, and then they want you to graph the function, and then we're going to begin analyzing it. So So end behavior, asymptotes, things that you have learned. Okay, so your very first one, I would like you only to watch because this is a little confusing for some students. Let's go right up here so everybody can see. Okay, here's your first one. Y equals 3 times 2x minus 1 minus 4. Okay, so we ready? Predictions. Here's the first thing I want you to do. There are 5 things I want you to do, and you're welcome to just verbalize these with your partner, okay? Let me fold this up. Okay, I want you to identify what is the y-intercept. Identify the rate, decide if it's growth or decay, and then I want you to make 2 predictions about translations. And translations would be, do you think this thing is shifted to the left or right, up or down? So 5 things, 1, 2, 3, and there'll be 2 translations to make predictions on. With your partner, you're welcome to write those down or just discuss those. I'm going to give you 30 seconds, go ahead. Okay, are you ready? You guys ready? If you're able to make these predictions and do this without even having to graph it, that means that you really have shown that you've mastered the concepts up to this point about predicting translation. So if you get it wrong, that's fine. If not, this is an opportunity to show what you know. So let's go with Anissa. Anissa, tell me one thing you know.
That the y-intercept is 0.
Okay, great job. By the way, what if I change this and this is the problem I gave you? What is the y-intercept now, Anissa?
0, 1.
Nice job. So I'm going to graph it, you're going to watch. So 0, 3. Can you raise your hand if you already knew that? Okay, tell me something else, Kevin. Why is it growth? Because A is greater than 0 and B is, nice job. A is greater than 0 and B is greater than 1. So I know this is going to be growth. So remember right now, growth is going to go, rises up to the right. Look at it from left to right. It rises up to the right. Nice job, Kevin. Okay, let's go next. Cortez, tell me something else you know. Okay, it might shift. Okay, good, it might. See how he puts that in? It might. I'm going to leave it. Which way do you think it's going to shift?
Right?
How many?
Does the 1 affect it at all? 'Cause I don't know.
Yeah, take a guess.
Right one?
Nice job. It's opposite of what you think for the left and right shifts. So right one is correct. Nice job. Brian, what's the next thing you know?
Down 4?
Down 4. Nice job. Down 4. Don't slam your hand on the desk. It's okay. Right 1, down 4. There's one last thing. Let's see. We're forgetting one thing still, and we're moving on to who's back there? There we go. What's the last thing? The rate. What is the rate? You may have said it and I can't hear you. And Brian's like trying to throw up fingers. And I don't know if he's like giving you gang signs or he's telling you math. 2. Nice. She saw the fingers. We're good. Okay. So 2 is the rate. So here's the deal. Ready? I want you, yes, you could plug this into your calculator and you could graph this in, fine, but you would not be understanding how it was built. So this is the parent function. We're basing it upon the rate of 2 and an initial value or the y-intercept of 3. I'm gonna first graph this and then show you how we translate it from there. So remember, you're just watching on this one. So I start at 0, 3. Now when I go over 1, and am I adding to the y value 2 or am I multiplying by 2? So it's going to be over 1 and up 6. Over 2 and up. So this is at 1, 6. And now we're going to go 2, 12, right? And the reason for it is we're multiplying the y value each time by 2. Now when I go in the opposite direction, please listen, you're getting a little chatty. Glad it's about math. When I go in the opposite direction, I take the 3 and I divide it by 2. So 3 divided by 2 is what as a decimal? Close, 1.5. 3 over 2 is 1.5. So it's not necessary to get any more points in this. Now here's the deal. This is what I'm going to refer to as kind of the parent function here. And notice that this will never cross an horizontal asymptote of 0. Now I'm going to shift everything and I'm going to use a different color so it stands out to you. So each one of these points, the ones that I have graphed, 1, 2, 3, and 4, each one is going to shift to the right 1 and down 4. And guess where I'm going to shift this horizontal asymptote? How many down? 4. So it's now going to go down 4. Okay, so here we go. Starting here at the beginning. So I'm going to go right 1, down 4. Right 1, down 4. 1, 2, 3, 4. Oh, I think I did this wrong here. Let me cut. Right 1, down 4. Right 1, down 4. So step 1 is making predictions, step 2 is graphing. What you see in pink is your final graph. Now step 3, there's 3 things I'd like you to do, and this relates back to what you already know. The first thing is we are going to state what is the new y-intercept. And I understand that my new graph is not very accurate. I can see it, but it's hard to see. Talk to your partner and come up, what is the ordered pair of the new y-intercept? So we're going to go from here. This is 1.5, 1.5, and we're going to go 1.5, that's 0.5, negative 0.5, negative 1.5, negative 2.5. And we'll be able to see that on a graphing calculator just to be exact. Your next thing I'd like you to do is what is the new horizontal asymptote? Written as an equation. Y equals negative 4. And the last thing is this. And this is what you learned with Mr. Edwards. Seems like a long time ago, doesn't it? As x goes to the left, now this is sometimes difficult for students. As x goes to the left, it gets closer and closer to this line. Do you agree? This is the line y equals what value? And as x goes to the right, it continues to go in which direction? That is ultimately what I want you to be able to do from this unit, okay? So turn to your partner. There's 3 parts. Your first part is making predictions. Turn to your partner in the next 15 seconds. Either help your partner or see if they can help you understand the predictions, okay? What are the translations? What is the rate? Is it growth or decay? And what is the starting point? 15 seconds, go. And stop. Thanks, guys. You ready? Here's your next thing. So I take away the translation, so forget about this moving to the right or moving down, and I graph that basic function. Okay, turn to your partner to make sure, in my case it happens to be blue, that you understand how I created the graph of the basic parent function. 15 seconds, go ahead. So you ready? Rosa N, you're going to help me out. Rosa, somebody's like, I don't understand how she graphed the one in blue. I get how she moved it in pink, but I don't understand how she graphed it. Rosa, what would be the very first step when you're going to graph this? Where do you start? Nice job. And what is the y-intercept again? So I start there. And Lorenzo, what do I do from there to create the graph?
Look at the rate
Nice job. Look at the rate. In this case, it is 2. Nice job. And what do you do with that number? Nice job. So we're going to take 3 times 2 is 6. 6 times 2 is 12. Moving to the right, I multiply by the rate. Moving to the left, I divide. So once I have these points, I'm going to shift each one of those points, right 1 in this case, and down 4. And lastly, analyzing. And I would say most students struggle with this portion. Okay? Talking to your partner, make sure they understand how to analyze based on these 3 things. Go ahead. 15 seconds. No, not vertical, horizontal. Because remember, it's like horizontal in the graph. Y equals 4, negative 4. All right, you ready? So here's your last thing you're going to do today. We have about 7 minutes left. Very last thing you're going to do. Grab your paper. You're going to start by making some predictions here. Y equals... I gotta look at my last one really quick. Give me a second. Equals 4. Bless you. 2x minus 2 minus 6. Okay. Dang, Kevin says. Okay, you ready? So 5 things I want. 5 predictions, and you can just verbalize those. 5 predictions, and I'm going to give you 30 seconds. Ready? Begin. Okay, ready? Predictions. Let's go quick. Ready? Raise your hand if you can tell me one. We want to get through this problem so you're ready. Give me one. Go ahead. Abby?
The y-intercept is
0.4 is y-intercept. That's correct. Andy, give me another one.
It goes down 6.
Okay, so he says everything shifts down 6. Give me another one, Rosa A. Shifts to the right 2. Carlos, give me another one. The rate is 2. Is it growth or decay? How do you know it's growth?
Because the A's are larger than 0 and the B is larger than 1.
Great job. Okay, ready? I want everybody to take in a piece of paper to give me a general graph of this. And you only have to give me, we're going to say 3 points on your graph, okay? 3 points on your graph. Go ahead. 1 point to the left of the y-intercept and maybe 1 or 2 points to the right of the y-intercept. Okay, I've not called on you, Daniel. How do I start this off? Where do I start graphing? Which is? Thank you. Amy, what do I do from 0, 4? So, tell me what the next point is. 1, 8. I can see after this I'm going to be off the graph. Can everybody see that? So for me to go to 216, it's not real realistic, right? So I'm okay with that. Amy, tell me what the next point is and how do you achieve it? By 2, because that's a rate, and you end up with 1, 2. Okay? If I'm going to take a highlighter just so I can see what the original horizontal asymptote is. Your original will always be y equals 0. I'm so sorry, guys. There we go. A little bit better. And I'm going to connect those points. Lupe, what do I do now?
Oh, that's all that?
Yeah, so tell me what do I do from each one of these points?
Well, what I do, like in the starting point,
You're right, starting point.
I go to the right 2
Okay,
and down 6.
hold on. Okay, tell me the next one.
And then,
I'm gonna do that with all of them for you, Lupe, okay?
yeah.
Give me a second. Okay, you ready, guys? I want you to do one more point for me to the left. So this is the point -1, 2. If I told you to come up with one more point to the left, what would it be, Joaquin? This is -1, 2. Use the rate to tell me what the next point to the left will be. Okay, I'm going to give you a hint. Ready? 0, 4. Now when I go to the right, I multiply by 2. So 0, 4, and 1, 8. Now when I go to the left, I divide by the rate. So 4 divided by 2 is 2. 2 divided by 2 is... Don't overthink. That's okay, kiddo.
I can't do these. I hate these.
-2, 1. -2, 1. And the reason why I wanted you to do one more point is when I started graphing, I realized in order for us to correctly identify the y-intercept, I had to go one more to the left. So I have over 2 and down 6. What did I do wrong here? Over 2, down 6, over 2, down 6. Okay. Then I'm going to take the horizontal asymptote of y equals 0. I'm going to move it down 6. So I know this graph gets closer and closer to that line, but it never touches it. Okay, ready? I'm going to ask you a question. Turn to your partner and answer. Ready? Here's the first thing. What is, in the blue line that I'm looking at, the official equation, what is the y-intercept? Go. 0, -5, right? Okay. What is, now you give me the equation. What is the equation for the horizontal asymptote? Y equals -6. What is the end behavior? So as x goes to the right, what's happening? As x goes to the right, it's going up, positive infinity. What about as x goes to the left? -6.